Hello, everybody. Last time we talked about BSD system and how it was configured and what are the different kinds of directory structures and other things. Today we are going to look at a little bit more deeper into how the system functions and things like that. Okay, so basically you have a hardware for which you have some kind of different units. Or the hardware might have, a processor, a memory unit, a EEPROM, EEPROM. Then you have flash, you have other kinds of device, I/O ports, and you have serial port, parallel port, and things like that, and bus also. Okay, so that is the basic, and your motherboard. Okay, so these are the basic things of a hardware. Okay, when you have the hardware and you're going to overlay some kind of operating system over that, the first level of writing a software is called device virtualization. Okay, what is device virtualization? Virtual means something to do with logical partitioning. Okay, logical partitioning of the hardware into a software system. So first thing, you have to logically partition the software. Okay, so software group, or what kind of functions you want to do, those kinds of things are all logically partitioned. Okay, logical thing means you have to see the whole thing as a kind of logical unit rather than the hardware. Okay, the hardware is the underlying thing. Okay, underlying thing is like the processor, the signal processing unit, and things like that. Okay, so the basic thing, while BSD was developed, it was first developed as a kind of signal processing unit. Okay, the first signal processing unit was the first kind of basic operating system that was done. Okay, and they had a small EEPROM for that, and from the EEPROM it will just take out the code and then run the signal processing, and signals will come in and signals will go out. So that's basically input output processing. Okay, so input, when the input comes in, you process and send the output to the other side. That's all. Okay, so that is the basic thing when the first BSD systems were developed. So basically the AT&T system, the telephony systems, and some of the signal where it is used, those kind of things were used. Okay, so the basic chip that was available at the beginning was a signal processing chip, but it didn't have any kind of software or kind of high levels of processing and other things. Later they wanted to introduce more kind of processing into the signal kind of structure, so that is why they developed all the processors and other things. The processor architecture can be 32-bit, 64-bit, 128-bit, or 8-bit processor, and even 4-bit processors are available on the board. Okay, so the BSC systems, when you have to do a complete virtualization of the things. There are different levels of virtualizations. What are the different levels of virtualization? First thing, you have to do a hardware virtualization, or physical layer virtualization. Okay, so physical layer virtualization is the first level of writing a kernel code. Okay, what is a kernel? Kernel got different kinds of shell layering. Shell have you seen shells? Okay, just like a kind of a nut over which you have layer after layer of shelling. Okay, so to get the access into the inner core, the inner core will be the hardware will be the processing unit, and some of the things are memory units, some of the things are EEPROM units, and some of the things are network units, some of the things are IO ports, some of the things are serial port, parallel ports. You have bus, different kind of types of bus, access buses, and different kinds of things, and you have to do what is called the first level will be device virtualization. Device virtualization in the sense, like, all the devices in the system will be virtualized. I talked about inode entry. Inode entry will be the first thing, which will be as the level of hardware mapping onto the software mapping kind of interface that will be done. Okay, so inode structure will be, I told you about already, it has got two different types of structure. One is a directory entry structure, and another one is file system structure. Okay, so the directory entry structures have other links to other kinds of pointers and other things, which will have a complete kind of numbering system. Okay, so it is a directory entry, and file system entry will be having directory direct of this is directly mapping. Inode numbers will be mapped, so they are all numbered as a kind of numbering system. So the first level will be numbering system. That gives you a level of virtualization of all the different hardware units. Okay, so it's a number processor number one, and you IO port, some IO port as number two. So those kinds of numbers are there. So the number things will be the first levels of virtualization. It is called the hardware virtualization, or physical layer virtualization. Then you have a data level virtualization. Data level virtualization is like how you process the data or the memory units and use those memory to can manipulate the different kinds of devices, and how we read and write onto a particular device, or write onto a particular port or something else. This is called port virtualization, or device of or levels of data link virtualization. Okay, then you have network level virtualization. Level virtualization is something to do with where devices are available outside the system, basically. So that is network layer virtualization. So you have physical layer virtualization, data virtualization, which is something to do with memory, and then you have network virtualization. So after that you have other levels of virtualization like transport virtualization, physical data network transport level virtualization, session level virtualization, and these are all different kinds of virtualization that you use. So because of virtualization, you can access those things as a virtual kind of unit rather than the physical kind of unit. So when you want about 10 processes are there, so that is a physical layer virtualization which will be done first to do the command for the particular kind of system architecture. So different kinds of system architectures are available. There can multiprocessor architecture, it can be single processor architecture, it can be IO device architecture, or can be simple signal processing architecture. Over the BSD systems has to be run, and you have to do all the manipulations for that. So basically the BSD system have two things. One is called a documentation. Documentation is where it completely gives you the command list, what kind of commands you can use, what kind of things you can do with the system. Those kinds of things are all what kind of different layers of shell, what are the different shell layers and things like that. So the first layer will be a kernel shell. Okay, so that is called a kernel shell. Okay, so that is called a KSH. Okay, that is usually used by super user. It will be only under single user mode, mostly to do with single user mode. Okay, then you have a group level kind of shell. Okay, so that is another kind of different kinds of shell. Then there will be another level, user level shell. Okay, so that is kernel shell, bond shell. Then you have S shell, and other kinds of shells are there. Okay, different levels of shells are basically how the access methods are produced at each levels of device virtualization. Okay, so the device virtualization metadata is the one which is used for device virtualization. Every layer has got what is called a device virtualization, and each has got as a kind of metadata for each one of those services. Metadata is basically file system kind of thing. Okay, so basically metadata will be in a kind of file system type of organized kind of thing which will be used. Okay, the first levels of device virtualization, as you see, is device is a kind of device. So if you go into SRC source, okay, so the two things that are available is document and source. Okay, so document is mostly used to do with BSD systems, where you have all the documentation completely written, what kind of things are available within the BSD system and what kind of virtualization. This is for writing any kind of operating system. So this is a general overview of how to write an operating system and other things. Okay, so virtualization is first method which you have to have a clear concept of what is virtualization and what is the levels of virtualization. Okay, so physical layer virtualization, data or data link layer virtualization, and you have network layer virtualization and other kinds of virtualization higher levels like TCP layering and other things. Okay, transport layer virtualization, session layer virtualization, and those kind of things. So each levels of virtualization is used for configuring the thing as a kind of virtual unit rather than as a kind of physical layer. So you're independent. So the upper layers are all independent of the lower levels of hardware components that are available. So hardware components can be here, or you can have a hardware component somewhere in London or Germany or France. These things have to be linked together as a kind of cloud and other things. These cloud possibly, when you give a print somewhere in London, and if you want to print it on a printer which is somewhere around Germany or France or something like that. Then you have because of device virtualization, you are able to do a print on some other printer somewhere else. Okay, so the device virtualization, this kind of device virtualization is mostly possible by addressing units. Addressing is the basic methods of device virtualization. That is, you have IP address. Some of the things of internet kind of things are all divided by IP version 6, which will give you a device virtualization of higher order. Okay, the basic physical layer ordering of device virtualization is what is called the inode numbers. The inode numbers are the ones on the lowest level of device virtualization. I know numbering systems and things like that. Okay, the two types: directory entry and file system entry. Okay, file and direct. Okay, file and direct. These are the basic things of device version or the physical layer level of writing a BSD code. So the shell layer has got different kinds of shells. Okay, let us go into session and see what are the different kinds of shells available. The first thing is you have when you want to go into shell level, the first level of shell that will be available will be kernel shell. Okay, so kernel shell, let's go look at what is kernel shell. Kernel shell is the basic thing which is going to run the operating system. Okay, so that is the kind of operating system that is going to do. So where it will be available, that is what we have to see. So one is called contrib, crypto, etc. GNU include kerb, OS, and libexec, release, rescue, sbin. Okay, so the sbin is the one which is going to have bin means binary. Okay, so shell binary will be available. System binaries, when the system is going to use those kind of things, the system binary or the shell binary will be available in sbin. So once you go into sbin, then you have different kinds of labeling and other things. Okay, so you have ddv, those are all device virtualization. Dev device match, message, dump fs, those kind of things are all fdisk. These are all something to do with fdisk is something with file disk. Okay, file fs info, so file system. Instead of file with the fs info. Okay, file system is given as a fs info. Okay, so fsck is the file system clock and the clearing unit, and db and other things are used. G is something to do with group management or gates management. Gate management tunneling through one layer of shell into other ones. Okay, grow and hassle. Unit is the first process that is run on the system level, first level of a process that is run on the motherboard. Okay, so the first level of process that will be running on the motherboard is init. Okay, before that, what is called, you have to do all the BIOS test, IO test and other things. So that the test will be test run will, that is called a BIOS test. Okay, so the BIOS test, input output, basic input output test will be done as the first layer of this thing, which is first layer of device virtualization. Once they do device virtualization slash etc dev etc, so it will be available easy to etc device. Okay, device files. Okay, device files will be the first one that is created for device file types and device directory entry types. Those will be the first thing that will be created, and each one of those devices will be checked for sanitation or something like that, doing tests for all each one of those, whether you can read and write the port and those kind of things will be first done. Then we have system commands like make node and these kind of nfs or iod. These are all system commands. Okay, so these are all system commands that is available. So these are the basic things of kernel system commands that is available. Kernel system commands, the first layer of device to devices, different kinds of devices or processor and other things, and devices, different kinds of devices. That's the first level of virtualization that is done. Okay, so file system also is so these are all the commands that fdisk, fsinfo, fsck, fsfs, dosfs, fsdb, so file system debugger, fs irad, so irad random generator, GBD is the global thing, Gate is the gate. So semaphores, the basic methods of accessing certain things. So if you want to do access of different device files and you want to queue things to it, then That will be the kind of the unit will be the first process that will be running on the processor, and it will do all the different kinds of device management, and it will be taken. It will be the first thing which will create all kinds of daemons are what these daemons are the ones which take care of different layer of virtualization. Okay, so daemons are the ones which are going to take the support for the different levels of virtual commands that you can give. So a shell will be having a daemon. Okay, kernel shell will be having a daemon. So then you have physical layer daemons, then you have data link layer daemons, then you have network layer daemons. These daemons are the background kinds of process that will be running, and they will be serving on a particular process. Okay, that is serving on the different kinds of commands that you give, and if you find the gate for those kinds of things, do semaphores for these different kinds of devices, and then finally give you this. So the kernel will be the first one which is going to use the init process, the first one which is going to use, and mounting is something, similarly mount a particular device onto a thing. So before that there is no if you want to read or write into a port or something like that, then you have use mount. Okay, once you do mounting, then you can just read and write into a port and things like that. Some devices allow for reading and writing, some devices won't allow for, they are just for read only purposes and those kind of things. So each device is created based on what kind of functionaries it can do, the physical layer functioning it can do, and device virtualization will happen in each one of them. Okay, so this is the basic command set that is given. Okay, edge kernel BCTL. So even the terminal types, and for the character state, those are all different kinds of support that is given. So the basic BSD system supports different types of kernel types, different types of device, different types of processes, different types of network layering, different kinds of virtual addressing. So these kind of virtual addressing also is needed because you want to do a virtualization of the whole thing, and the whole thing is looked into as some kind of file system based on what is the kind of inode entry that you have. So the inode entry is the basic map of the thing which you have access only through a system command as the system shell. Okay, so that is called a shell, SSH. Okay, system shell, that is called SSH. That is the basic thing which is going to give access to different kinds of devices and others. So the first layer of shell will be SSH. Then they have GSH. Okay, G shell, that is the next layer. So SBIN will be the first thing directory which will have all these different kinds of things. Okay, now if we go into sys, okay, let's go into sys. Okay, there are ports. Okay, ports and shell. Okay, so there are ports means IO management, then shells means things which are going to support those kind of processes. So the thing which is going to run on the processor, it is going to be a shell kind of commands, and things which are going to manage the devices is called a port. Okay, so they are configured into two types of things. One is called a port, another one is called a shell. Okay, so kernel code or the processor kind of thing. So that is why shell will be basically running on the processor. Okay, the processor usually takes the next command. Okay, so it is a kind of the next the instruction. Okay, so basically when you look at a processor, it is going to take the next instruction and execute the next instruction, and increment the counter and go to the next instruction. So the instruction set is based on what kind of processor are available. Okay, processor, different kinds of processor allow for different kinds of instruction set over which you can do addition, multiplication, subtraction, division, and those kind of things, and how we can do all the different kinds. So each one is going to give as an assembly code kind of thing. Okay, so assembly level will be the first layering of kind of higher levels of language virtualization. What is language virtualization? Bits are the ones which are the basic things of zeros, and ones are the hardware virtualization. Then you have if you have assembly language, that is a language virtualization of the bits and things of the instructions to a higher level. Then you have higher levels of C programming and C++ programming, and then you have HTML programming. Those are all language virtualization. The language virtualization is the kind of thing which is used for how to use different kinds of commands on different layers of shell, and how we can use those things as a kind of target machine system and other things. Okay, so let's go into sys. Okay, sys is the one which is going to give you all the things. Okay, so this is First, AMD 64. So AMD 64 is a specific kind of processor. So all support infrastructure for the particular process AMD 64, 64-bit processor, advanced micro devices 64. Okay, so advanced micro devices processor support will be done, 64-bit processor support will be done, all the particular commands for those things and all the different types of access methods and other things, all is given by AMD 64. That will have the complete entire structure for the processor architecture. ARM is another one. Okay, ARM is another kind of processor which is going to support all the ARM 64 is the other kind. So ARM is 32-bit or 16-bit, and ARM 64 is a 64-bit processor, and that is the different kinds of processor which will be support. So the basic two different types of processor support will be there, AMD 64, ARM. Okay, 64 or 32. That so bit and byte conversions for those things, byte swapping, this is another one which is used. Okay, bit conversions, these are all things which will be used for different kinds of processor architecture. So if you want to change from 8-bit computer to a 16-bit computer, those kind of supports will be given as a different kinds of process support. Okay, BSM, CAM, okay, CDDL. Okay, so this is kind of change directory and directory structures, and you want switch from one directory to another directory, and device kind of layering, those things will be CDDL. Okay, config, contrib, crypto, DDB is the device debugger. Okay, so device debugger is all the devices can be debugged, for find out what is the problem with each one of those devices. Those tunnels or semaphores will be available only through DDB. Okay, so device files, div is another one which is going to give you all the devices. Let's go into check into what is devices in there. Okay, there are different kinds of devices. AAC. Okay, AACAIRD, this is a RAID unit. Okay, RAID unit is CASI disk. Those are all the RAID units which support. So device supports are all ADB is another, add link is another one, AE is another one, AG is another one, AH is the different kinds of AI Ethernet. So Ethernet can be accessed through AI Ethernet. Okay, so these are all different types of hardware unit virtualization that is given for the device. So different types of devices are there. Processor is another one, but other kinds of devices are given all this kind of device virtualization. Okay, anything bus access, IO port access, those things are all given. Copy is the file system command. So if you want to copy from one device to another, and those things are all for device, and other things will be given by CP and other CMD, and these are all commands. DWC, these are all commands that will be used for accessing different types of Ethernet device and other kinds of file system device. Flash is available. All the flash entries. Flash means this is a kind of device. So all the virtualization of flash unit will be done by flash. Okay, so all the support structures for those etc files, the header files, all the support things will be done by flash. Okay, similarly, GLXIEC, those okay, GPIO, those are HID is there. Another one which is going to be used for HP hyperversion and ICE. Okay, ICIE, all this I thing is something to do with process support system. Okay, so those kind of the IEC, CSB, IGC. Okay, Intel support is completely device virtualization. Intel support is all given by Intel, things will be there in this. Okay, IPS is the inter-process communication systems. Okay, IPS is inter-process communication. If you want to do to different processes, if you want to communicate between those kind of process, those support structures, all the device files, all the support infrastructure. So because the shell is going to do all these things. Okay, it is going to create all these things, device support and other things. Okay, so let's go into sys and shell. So the basic shell will be kernel. Okay, libkernel, modules with the different kinds of modules that you can access. Okay, as a kind of file system modules or kind of net modules, and net graph is another one, netinit is another one. Netinit is the kind of inode structure which will be used for network related kind of things. So network kind of things. Then you have TTT types. Okay, this is also NFS. Network file systems are all given by NFS. Okay, RPC is the remote procedural call. So if you want to call a function which is outside the system and you want to execute in some other machine outside the system, that is, those supports are all given by RPC. Security is the kind of layering for security system, token, and tests and tools. And US unified file system is a kind of unified file system where there's a single file system which you can just, virtual kind of file system which you can use for unified file systems. Okay, x86, 8086 older processes which are all 86 kind of commands, those are all given by x86. Okay, so this is how we make all the files for different kinds of shell layering. Okay, DDB and other things. Okay, now that's for once we are done for those are system supports. The basic system support is the first one. Okay, SSH. Okay, that is system shell layering. Okay, so that is the first level of things which you have to do. Okay, so the basic concept of writing an operating system is virtualization. Okay, there are different types of virtualization, so you have to take care of all the different types of virtualization. First thing, you are going to different types of devices, hardware devices, different types of processes, different types of virtualization, and different layers of virtualization for which user bin is the user binary commands. Okay, when a user is just going to use some kind of commands, it is given user bin. So that shell will be different than kernel shell. Okay, KSH. Okay, SSH is the basic shell. Okay, over which kernel shell is the next layer. Kernel shell is the one which is going to you allow for group commands to be done, and over which another shell will be used, U shell. Okay, U shell or bone shell. Bone shell will be the one which you can use for system commands, which you can use for user. Okay, so user executables will be run on sbin. Some of the accesses of user bin will be through sbin. Sbin is the one which is shell. If you want to access the internals of some kind of if you want to do a file system entry, those kind of support structures will be all given by user sbin. Okay, user bin is the normal commands of user which you can type it on the terminal and then get it back. Okay, so the user commands will be on user bin, and user sbin will be the kind of support structure which will be accessing the shells, different kinds of shells. And S shell is the basic thing. S shell will be the one which will be used for the kernel kind of thing. So Kerberos and other things are all other different kinds of shell. Board shell is another one which is the layer for kind of you accessing the different kinds of entity for as a kind of user level kind of thing. So that is where kernel shell, KSH, there are different kinds of SSH is the one shell, or SSH will be the first shell. Then we have kernel shell, then you have bone shell. So BSH, KSH, SSH. Okay, these are the three types of shell layering that will be used. Okay, so once you have GNU module and other things. Okay, so once you have done all these things, use the bin lib and other things, then you can go into support structure. GNU is the basic things of global network. So it's a kind of support structure for the compilers. Okay, GNU is the full support structure for the different types of why you need different types of compilers. Compilers are the ones which are going to do different types of compiler. It's called a cross compiler. The compiler for a particular machine system architecture for the particular kind of device will be done by GNU. GNU, there are libraries, though there are different kinds of libraries which do the support system for the GNU kind of thing. Okay, GNU is the one which is going to do the cross compiling for the different kinds of hardware architecture. So first thing you will be doing is a cross compiler. First thing, when you want to develop any kind of operating system, you will do what is called a cross compiler. Once you have done a cross compiler, because for that particular kind of hardware architecture, you have to first write the cross compiler. Once you have done the cross compiler, then you have to generate all the different kinds of bone shells, C shell, K shells and other things. Then you have to completely compile the entire environment for that particular kind of architecture. That is why you need a cross compiler to do it. Compilers are the basic things for that particular system, for that kind of target machine and other things. Generic compilers are used for kind of a device which are compiling systems, which are compilers are basically to the assembly language, to the kind of higher level language. That is why it's called GNU support. Okay, SRC we have seen. Okay, so GNE or SRC include files are the one which are going to include all the different kinds of library header files, the device addresses, and all those things with device address virtualization, mapping, and byte swapping, and things are all going to be used in include files. Okay, etc file is the one which is going to be etc directory, which will contain GSS, mail, M-tree, root, send mail, and term cap. Term cap is the one something to do with all the different kinds of terminal types. Send mail is the one which is going to kind of mail kind of devices. Root is the one which is going to root shell, which is going to be used as a kind of shell layering for all the root access. Okay, so those kind of things. Okay, then you have M tree is the device architecture tree structures. Okay, memory tree. Okay, so M tree. So memory will be used in M tree, and mail will be used different kinds of mail system. GSS will be the group shell systems. Okay, group shell systems. Okay, that is including curb OS. Okay, Kerber OS is a kind of device kind of thing, which is the different kinds of OS which can be done. So for debugging, kernel debugging, or those kind of things can be done by curb OS. Okay, so it has got separate S bin, it has got bin, it has got tools, it has library, exec libraries, and libraries and exec libraries are a little bit. One is called a shared library, another one is normal library, another one is called exec library. There are three different kinds of library systems they use. The library systems, they are used basically to access different units from different layers of layering. It is a kind of semaphore structures which you can use for accessing the different kinds of libraries. So one library you can call device library, one is for a tool library. Those libraries are all separate, and that is why they have lib and libexec. Okay, those kind of library structures and include for each one of them. Libexec, okay, ksh, kdc, okay, kfd, okay, k password, okay, kernel password, and this thing. So these are the different kinds of commands that you can give. So first thing is layering, giving commands to the things. Those commands will be available in binary. Okay, so finally the bin will be the one which will have all the shell binaries, will be all the different kinds of commands that is available on a particular layer of shell is given by S bin. Then after that, another levels of k bin will be the other one which is really, which will have other kinds of binary, kind of commands that is available. So commands are the one which are good, they are always available as a kind of binary. These command which are available in the binary will be executed one by one over the processor. The processor, there's something called a scheduler. Scheduler is the one which is going to schedule all the things, and the scheduling business is done by what is called a daemon. Daemon is run by first levels of daemons are all generated by each levels of layer virtual device virtualization, memory virtualization, and other things. File virtualization, and all these things is done by what is called the SBIN, and device manipulation and other things are all done by SBIN. So those binaries are all available in that particular system. Commands and system things are all standalone kind of things, where those kind of commands will be given. System is the basic system commands. SBIN will be the binaries for those targets, or the different kinds of targets, different kinds of devices, hardware devices that is available. So for different kinds of targets is basically different kinds of processors, different kinds of memory architectures, different kinds of bus architectures. Those kinds are all different kinds of targets that will be used. Okay, so a general overview of libexec are the basic two different types of library types which are available. These library types are the ones which are going to be used as a kind of libraries. So lib will be used as a kind of library call. Okay, libc and other things, but libexec will be called as a kind of command kind of thing. Okay, ATF, flaw, ftpd with an argument. So with an argument, it will be actually a call through the argument, getty, and those kind of process will be done. Okay, libexec is a kind of process kind of thing, whereas lib is an ordinary kind of support libraries for those kind of things, which those libraries support libraries for other kinds of execs. Okay, execs in the sense other kind of executables of different types of execs, user exec and other things. So for those RPs execs, those are all execs, or exec libraries will be the ones which are just for the executables and other things. And the library is a generic library, there is an executable library, kind of two different types of library systems that is available for virtualization. So So the concept of basic virtualization, what is device virtualization, what is physical layer virtualization, what is data virtualization, then you have what is file virtualization, then you have inode virtualization, why we need inode and why we need device virtualization. What basic first level will be inode. Okay, first level will be inode kind of thing which will be used for virtualization. Then the second level will be the device virtualization, etc. DEV, okay, EC, ETC, DEV. And third layer will be the kernel virtualization. Scheduler virtualization, okay, daemons init virtualization. Then we have kernel virtualization, which is the kernels, three different types of kernels that will be available to use: system level kernels, then higher level access, device access kind of kernel, then you have other kinds of kernels that will be available. Okay, so and you can call these things through what is called gates or semaphores. Semaphores is the basic things, and some of them have queuing structures which you can pump. And TTY is the kind of terminal types which will be used, whether it is the ASCII characters that you are going to pump in and get ASCII characters out, or it is like a touch screen, or you can have a visual screen and things like that, bitmaps and things like that. So those virtualization are all given for different device types, and those are all etc device kind of thing. Lib is the generic library for the entire system. Okay, that will have the library is for the entire system, which will have different kinds of the gates, semaphores that is possible through for a particular kinds of different layer of shell layering. Okay, so now you know have a complete idea of what how to write a operating system. Crypto is the basically for some kind of cryptic kind of thing. Okay, where you have byte swap, bit swap, and things like those kind of cryptic kind of thing. Kind of any kind of different kind of processor architecture, different kinds of bus architecture, those cryptography which is used, and those kind of things are all crypto kind of contributes from other system sources. Okay, there are some other things which people contribute to a particular BSD system based on the kind of different architectures or different kinds of hardware they use, and those are all contribution to the, like for like Windows will be contribute under Windows BIOS will be under contribute, because this doesn't belong to BSD systems and things like that. So those kind of things are all available in what is called a contribute. So the basic directory structure, how to use share is the one which is shared libraries, and how we can share all the different kinds of environments, and those kind of things are all available in a share. Secure is the one of protective layer. Okay, that is the kind of protective layer, that is a secure layer of access of different kinds of shell layering and different kinds of command structures, and different kinds of optional parameters that is possible, and who's the group ID, user ID, and those levels of access, and for the target system how to read and write it to a port, device ports, and other things. So basically device ports, file system, memory access. Okay, these are the basic things. I told you already about three different kinds of things with the tables, which will be three or four different: file system table, then you have IO table, then inode entry kind of table, then you have uh, uh, inode entry so different kinds of tables are available. Those tables will be used for kind of different access level methods. Process table, IO table, process for just for process. Memory table is the one which is good. Memory table is all the memory kind of things will be used by memory table. All the IO kind of things will be the IO table. Then all the input output and kind of device type of things are all done by input output IO table. Then you have shell tables which will be used as a file table, which will be used for all the different types of directories and file structures kind of thing will be also file table entry. And so basically four types of virtual this thing file system types, or tables that will be used: process table, process management table, IO management table, file system management table, and file system management table. Another one is memory management table. Okay, MMU, IPU, process table. Then you have IO table, IMU or something like that, and then after that FS, file system table. So these are different kinds of tables that will be used for entire manipulation of how to run the operating system, and how to start a daemon, how to start each one of the daemons, what they do, or what level of access they work on, and how using the daemons is just a kind of process which is going to do all the different kinds of level of virtualization support. Okay, it's a server kind of thing which is going to do all the different, and what is the command that you can give at each one of those, for the daemons, what kind of commands you can give, and that will be the basic process that will be running as a kind of daemon process. Once the daemons die out, then each one of those layering will be taken out, so you can just take each one of those layering and just the kernel layering alone can be there. That will be the deepest level of SSH will be the first layer of kernel shell, that is used for debugging and other kinds of modes. Okay, so basically have basic idea of how the whole thing works is the whole thing about the BSD systems. This was just generally for it supports for multiprocessing, single user multiprocessing and other kinds of processor device. So basic first level of things were signal processing and other kinds of flash devices and other things. Later it came into including all the different kinds of processors, the byte swaps and device types and all this. So the different levels of virtualization that happens and different types of library supports for each one of them. Okay, so that is all for today about device virtualization, how the kernel system works, what are the different kinds of shell layering, and why we need all this, what are the different kinds of commands it is available, how to make all the libraries, how to what are the difference between library and exec library and those kind of things. Okay, that is all for today. So this is the kind of thing when you're writing an operating system, how to write an operating system for different kinds, how to organize those things, and how to look into the whole entire system as a kind of cloud architecture and hyperlink architecture, those kind of all, how what are the levels of virtualization you give, so that you can use the commands on different layers and then use the system as a kind of what different levels of shell layering and things like that, how they are accessed through semaphores and other things. Okay, that is all for IO libraries. Interrupt handling is also another kind of, interrupt table is another kind of, interrupt table is the one which is for a particular device or a particular system or particular CPU and other things. There's another interrupt system table handling. Okay, that interrupt system table is mostly done by queues. Okay, queues are the ones which will, so you can clear all the interrupt right on the device on the particular interrupt device and other things. So the virtual device will have software kind of interrupts. Okay, there's two things, one is hardware interrupt, another one software interrupt. Hardware interrupts will be something to do with the specific kind of hardware that you're going to have, and software interrupts are the ones which are going to have the interrupts for the different levels of layering processing that is happening. So if you want to switch from one process to another process, immediately the software interrupt process, the IPC interrupts will be given, and those interrupts will be handled as a queue kind of thing. That is why the user also is not kind of unaware of what is happening at the background. There will be 5 or 10 users that will be using the system, but each one, because of the interrupt handling and other things, they are able to do, and using semaphores they can do different access to a particular device and other things. And queuing is the other one, which is interrupt queuing is the one which you have as a queue kind of thing, which is which if different groups of people carry or users are accessing a particular device, then you have the queue, and the interrupt generators or the tables are the ones which are used. So the basic things of how an operating system works is what are the different file systems, what are the different kinds of things, what is the different kinds of virtualization, what are the shell virtualization, what is the hardware virtualization, and other kinds of network layer virtualization and other things. Okay, that is all for today. So we have to understand all these things before we write an operating system for any other kinds of future OS and future cloud, memory cloud and other things. Okay, that is all for today about BSD.